All right, we're going to look at an example of what we can do to take a derivative where we can see that there's a function in a function, but maybe we also have an exponential involved. So for example, if y equals 2x to the sine of 3x. So one tool that we can use is this all by itself might be a little bit complicated to do with all the function in a function pieces of it. So one thing we can do when we have exponentials to try to simplify a little is take the log of both sides, or in this case, maybe because it'll work out nicer, or because between log base 10 and natural log is the more natural, obvious choice here. So we can use this to our advantage to try to get this out of the exponent. Because remember, when you have an exponent inside of a logarithm, you can pull it out front as multiplication. So now instead of looking like a function in an exponent that has a function inside of it, we can think of this as the exponent multiplied out front, so sine of 3x times the natural log of 2x, which at least instead of having this be an exponent in an exponent, turns it into something that we can either simplify a little further, or we could start doing product rule right now. One is if I have multiplication inside a logarithm, that's the same as two separate logarithms added together. So I could also try to use that to my advantage. So I have sine of 3x times natural log of 2 plus natural log of x. So maybe when I get to derivatives, that might work out a little bit better. Okay, so now I have to do implicit differentiation, right? Because I don't have it solved for y anymore. So if I take d dx of the entire equation, so the derivative of natural log of something is 1 over that. But to be careful, I'm doing y and not x. So derivative of natural log of y is 1 over y, but then it's times dy dx, since I did that with respect to y and not respect to x. And then I'll have to do product rule here because I have two things that are multiplied by each other. So maybe somewhere off on the side, not a bad idea to write down your two pieces for product rule. So f, the first thing that's multiplied, is sine of 3x. And the derivative of that is derivative of sine is cosine. So derivative of the outside times derivative of the inside is 3. So 3 cosine of 3x. And then the second part of this that's multiplied is right here. So if my g is natural log of 2 plus natural log of x, don't forget natural log of 2 is just a number, right? It's e to the what gives you 2. Natural log of 2 is a constant, so the derivative is 0. And the derivative of natural log of x is 1 over x. So then when I put my product rule pieces back together, I have this times this. So 1 over x times sine of 3x. Plus this times this. So 3 cosine of 3x times natural log of 2 plus natural log of x. And notice at least that was all x, so I didn't have to add any dy dx's in there. All right, so then the last thing I want to do is try to get dy dx by itself. Good thing we don't have to do a crazy amount of simplifying here. It got a little bit long, but still, we're just asking for the derivative, so we don't have to do a whole bunch of simplifying. So to get dy dx by itself, I want to multiply both sides by y, right? Because I'm trying to cancel off this 1 over y. And so the y times 1 over y cancels. So I'm essentially done. The only thing is you don't usually like to leave y in your answer, right? And so if we look back to our original problem, in our original problem, y was equal to this exponential that we didn't want to deal with. And so we can just put our choice for y back in there and say dy dx is equal to all of this and the product rule piece we did times, and instead of y, we'll put what y is equal to, which is 2x to the sine of 3x. So that's a nice little way to get everything back in terms of x, is look back at the original problem and it said y was equal to this whole thing. You can replace y with that at the end. So now you have your whole function in terms of x, and you didn't have to do any crazy solving. We got to just use implicit to get to the derivative without getting y by itself.